That orange blob on your fence post appeared overnight. It was not there yesterday. It will be gone in 72 hours. And in that window, it is doing something to the wood beneath it that no fungicide product on the market replicates. Section 1. What it actually is. The orange blob on your fence post is not a fungus. It is not a plant. It is not an animal. It is a slime mold, a single-celled organism, classified in the kingdom Protista, that exists entirely outside the biological categories most people use to understand living things. The species most commonly appearing on fence posts, wooden decks, and garden mulch across North America is Fuligo septica, commonly called dog vomit slime mold. It can cover a surface area of several square feet from a single organism. Every orange cell in that blob is genetically identical and behaviorally coordinated without a brain, a nervous system, or any centralized control structure. How it moved there. Fuligo septica spent the weeks before you noticed it, living as microscopic individual cells in the soil and organic matter around your fence post. Each cell moved independently through the soil-consuming bacteria and fungal spores as it traveled. When environmental conditions aligned, specifically a combination of high humidity, moderate temperature between 60 and 80 degrees Fahrenheit, and declining light intensity, those individual cells released chemical signals that drew them together into a coordinated mass. The aggregation traveled as a unified organism toward the fence post surface following moisture and food gradients. The movement you did not see happened at a rate of up to 1 centimeter per hour through the night. The blob you found in the morning traveled there while you slept. What it is doing to the wood. The slime mold covering your fence post is consuming the pathogenic fungi living in and on the wood surface. Fuligo septica feeds by engulfing food sources in a process called phagocytosis. It surrounds fungal colonies, bacterial populations, and organic debris on the wood surface, and digests them internally. The pathogenic fungal species it consumes include the early-stage colonies of wood rot fungi, including Trametes versicolor and Ganoderma species, that establish in weathered exterior wood and begin the structural decay process from the surface inward. A fence post with an active slime mold event on its surface is having its early-stage wood rot fungi removed by a biological agent that costs nothing, leaves no toxic residue, and completes its work within 72 hours before moving on or sporulating. The 72-hour cycle. The 72-hour window referenced in the title is the complete plasmodial phase of the slime mold life cycle. During that window, the organism is in its most active feeding state, consuming surface pathogens and organic debris at maximum rate while traveling across the substrate. After 72 hours, the plasmodium transitions into its reproductive phase. The orange mass begins darkening toward brown or black as it forms sporangia, the reproductive structures that will release spores into the surrounding environment. Those spores disperse on air currents and settle into surrounding soil and organic matter, where they remain dormant until the next aligned set of humidity, temperature, and light conditions triggers a new aggregation event. Touching or disturbing the slime mold during its active plasmodial phase disrupts the feeding process and scatters the organism before it completes its pathogen removal work on the wood surface. The 72-hour instruction is not caution about toxicity, it is instruction about function. Let it finish. Problem-solving intelligence. Fuligo septica and related slime mold species have been the subject of significant scientific research into biological intelligence systems that operate without neural tissue. A landmark study published in Science in 2000 by Toshiyuki Nakagaki at Hokkaido University demonstrated that Physarum polycephalum, a closely related slime mold species, solved a maze problem by growing through the most efficient pathway between two food sources while retracting from dead ends. The organism had no brain, no neurons, no nervous system. It solved a spatial optimization problem through distributed chemical signaling across its cell network. Follow-up research at the University of Sydney in 2012 demonstrated that the same species could anticipate regularly timed environmental events and adjust its behavior in advance of their occurrence. The slime mold on your fence post is running the same distributed decision-making system that scientific researchers have spent 20 years trying to understand and replicate in computational models. It arrived at your fence post by solving a navigation problem your garden presents every time humidity and temperature align. Pest company response. A homeowner who photographs the orange blob on their fence post and sends it to a pest control company receives one of two responses. The first is a recommendation for a broad-spectrum fungicide application to the fence post and surrounding soil. The second is a recommendation for a general exterior treatment addressing whatever category the technician assigns the organism to after misidentifying it as a fungal growth. Both responses apply chemical product to an organism that will be gone within 72 hours regardless of any intervention and that was actively removing pathogenic fungi from the wood surface during its presence. A fungicide application to a slime mold does not accelerate its departure. The slime mold is not a fungus, and most fungicide active ingredients do not affect Protista species in the same way they affect true fungal organisms. The application kills the surface bacteria the slime mold was also consuming, removes part of its food source, and may slow its feeding activity without eliminating it. The service fee runs between $80 and $150 for treating an organism that was providing free wood surface remediation and would have completed its work and departed on its own biological schedule within 3 days. Wood protection value. The pathogenic wood rot fungi that Fuligo septica removes from fence post surfaces during its active phase are the same organisms that structural wood treatment products target with chemical preservatives. Copper azole, the active ingredient in most pressure-treated lumber and wood preservative products sold at hardware stores, works by killing the same Tremites and Ganoderma species that the slime mold consumes through phagocytosis. A fence post preservative treatment using copper azole concentrate runs between $15 and $40 per application and requires reapplication every 1 to 2 years as the chemical leaches from the wood surface through rainfall and soil contact. The slime mold event on your fence post is applying biological fungal removal to the same wood surface for free every time environmental conditions align. It does not leach away. It does not require reapplication scheduling. It recruits itself from dormant spores in the surrounding soil when the wood surface presents a sufficient food source in the form of early-stage fungal colonization. The fence post that supports regular slime mold events across its service life is receiving intermittent biological remediation of exactly the pathogenic organisms that cause structural wood decay. That biological maintenance extends the functional lifespan of the wood from the outside inward in the same zones where chemical preservatives work from the inside outward. Soil benefit after sporulation. When the slime mold completes its plasmodial phase and transitions to sporulation, it deposits more than reproductive spores into the surrounding environment. The sporangia that form as the orange mass darkens contain concentrated packages of the genetic material and chemical compounds the organism accumulated during its feeding phase. As those sporangia break down and release their contents into the soil and onto the wood surface, they deposit bacterial and fungal fragments in a pre-digested form that soil biology processes more efficiently than intact organisms. The nutrient pulse that follows a slime mold sporulation event in garden mulch or on a fence post base is measurable in the soil chemistry of the immediate area within 2 weeks of the event. Soil bacteria populations spike in response to the available nutrient input. That bacterial population increase drives a secondary increase in the predatory nematode and protozoa populations that feed on bacteria, accelerating the entire soil food web cycle in the immediate zone. The spores themselves carry functional significance beyond reproduction. Slime mold spores deposited in soil after a sporulation event remain viable for years under dry conditions. They carry the genetic information of an organism that successfully navigated to a food source, consumed it, and reproduced. The next aggregation event, triggered in the same area, starts with spores already adapted to the specific bacterial and fungal populations present in that location. The slime mold population becomes progressively better calibrated to the specific pathogen profile of your fence post and surrounding soil across each successive event. That adaptive calibration is not a feature of any chemical wood preservative product on the market. The cascading biology that follows a single sporulation event extends further than most soil ecologists expected when they first began documenting it. The predatory nematode population increase, triggered by the bacterial spike, creates pressure on the bacterial community that stimulates bacterial reproduction in response. Bacterial populations under predatory pressure reproduce faster and produce more metabolic byproducts per cell than unstressed populations. Those metabolic byproducts include enzymes that break down complex organic molecules in the surrounding soil into simpler compounds that plant roots absorb directly. The slime mold sporulation event that appears to end when the orange mass darkens and collapses is actually the beginning of a biological cascade that runs through the soil food web for 2 to 4 weeks after the visible organism is completely gone. The fence post base where sporulation occurred becomes one of the most biologically active soil zones in your garden for the month following the event. That biological activity is invisible. The orange blob that preceded it was the only visible indication it was happening at all. Total value calculation. Here is what one slime mold event on your fence post is worth across the 72 hours of its active phase and the years of biological benefit that follow. Wood rot fungal removal during the active plasmodial phase replaces one application of copper azole wood preservative concentrate, valued at between $15 and $40. A fence post receiving regular slime mold events across a 10-year service life receives between 5 and 15 biological remediation events, depending on climate and local spore density. At replacement preservative cost of between $15 and $40 per event, that represents between $75 and $600 in wood preservation value delivered at zero cost across the post's service life. Soil biology enhancement following sporulation produces a nutrient pulse and bacterial population increase that reduces supplemental soil amendment requirements in the surrounding garden area. The bacterial population spike following a slime mold event delivers nitrogen and phosphorus in plant-available form, equivalent to a light fertilizer application across the immediate zone. At fertilizer replacement value of between $5 and $15 per event across 5 to 15 events over 10 years, that represents an additional $25 to $225 in soil amendment value. The fence post lifespan extension from regular biological fungal removal is the largest value component and the hardest to calculate precisely. A fence post in ground contact without any fungal management fails structurally in 7 to 12 years in most temperate climates. A post receiving regular chemical or biological fungal suppression extends that lifespan by 3 to 7 years. Replacement cost for a standard wooden fence post installed in ground runs between $25 and $80, including materials and labor. The slime mold that costs nothing and requires no intervention potentially delays that replacement cost by years. The orange blob you were told to remove was providing more measurable value to your fence and your soil than the $150 fungicide treatment that would have replaced it. The neighborhood scale calculation adds a dimension that individual property value misses entirely. Slime mold spore dispersal after sporulation covers a radius of between 10 and 50 feet, depending on wind conditions at the time of spore release. Every fence post, garden bed edge, and mulched tree base within that radius receives a deposit of adapted spores calibrated to the specific pathogen profile of the originating event. A single slime mold event on one fence post seeds the biological remediation capacity across the entire immediate yard perimeter in a single sporulation. Neighbors whose fence posts share the same spore dispersal zone receive the same biological seeding without any action on their part. The organism that the pest company charged one homeowner $150 to remove was in the process of providing free wood surface remediation to every wooden structure within 50 feet of the treatment site at the moment of the service call. The fungicide stopped that distribution. The invoice covered the cost of ending a free neighborhood-wide biological service that had been running on wind and humidity for years.